Greetings and welcome to this presentation on Ireland's new national rules for electrical installations. The national rules for electrical installations are prepared by Technical Committee TC2 of NSAI, which is the National Standards Authority of Ireland. This presentation by TC2 outlines the key changes in the new rules and is not intended to be a training course. Electrical installations should be undertaken by registered electrical contractors who have the training and experience required. The legal basis for the national rules is the Electricity Regulation Act of 1999. The Electricity Regulation Act established the Commission for the Regulation of Electricity, CER. Later, CER also took on regulation of gas as a utility and then water, and CER has now been renamed to the Commission for Regulation of Utilities, CRU. The regulator is given specific tasks under the Electricity Regulation Act. One task of the regulator is to regulate the activities of electrical contractors with respect to safety. This means the regulator does not tend to intervene in, for example, employment practices, costs charged, or how the electrical contractor deals with their customers. The regulator duty extends primarily to safety. To achieve this, the Electricity Regulation Act identified particular tasks for the regulator, including the regulator was required to set up a register of electrical contractors. This register is now maintained by RECI, who are also called Safe Electric. The regulator was also required to set up a Safety Inspectorate, CRU, has appointed RECI Safe Electric as the inspector, and RECI electrical inspections take place right across the country. Of particular interest here, the regulator was required to have a set of electrical rules. The regulator achieved this by naming ET 101, National Rules for Electrical Installations, as the official rules for Ireland. Therefore, National Rules for Electrical Installations is now empowered by the Electricity Regulation Act. ETSI, Electro-Technical Council of Ireland, created and published the rules ET 101. For reasons beyond the scope of this presentation, the task of creation and publication of the rules is now transferred to NSAI, National Standards Authority of Ireland. National Rules for Electrical Installations is now revised, and the old ET 101 has now been replaced by the new Irish standard IS 10101. Ireland's national rules for electrical installations was ET 101, with the 4th edition published in the year 2008. A lot has changed in the electrical industry since 2008. The speed of change of the electrical industry is increasing. Electronic advances change the types of electrical protection that can be offered. The types of installations have changed dramatically too, with data centres and electrical vehicle charging and solar PV panels not even considered in 2008. Fire regulations are changing to offer improved protection in buildings. UK wiring regulations are on their 18th edition, but Ireland was only on its 4th edition. Ireland had a lot of catching up to do. New wiring rules were way overdue. In addition, IEC and CENELEC standards had changed dramatically and Ireland needed to catch up. National Standards Authority of Ireland, NSAI, is Ireland's representative on CENELEC, which is the European standards body for electrical installations. And also on IEC, the International Electro-Technical Commission, which is the international standards body. IEC and CENELEC develop electrical standards for all countries. Ireland participates in the creation of the new standards, and Ireland has a vote on IEC and CENELEC. Once every member state is agreed, the new standards documents become European harmonised documents, and then these documents and rules must be applied in Ireland. NSAI Technical Committee TC2 mirrors IEC TC64 in creating rules for electrical installations. NSAI TC2 works must then mirror or copy from IEC TC64. The primary scope is protection against electric shock. Therefore, the primary objectives of national rules for electrical installations are protection against electric shock, covering voltage up to 1 kV AC only, safety requirements only, and the rules do not cover individual items of electrical equipment. IS 10101 therefore does not mandate the quantity of sockets, outlets or lights that you install, but deals only with the safety of the electrical wiring and installation. IS 10101 does not deal with the cost of any installation. IS 10101 does not deal with other aspects of a building or installation, such as planning permission, room sizes, or disabled access. Other regulations govern these areas. IS 10101 only deals with the electrical safety of the installation. Another key point to note is that IS 10101 deals only with the wiring installation up to the socket or isolator. IS 10101 does not cover energy utilising equipment. NSAI and international standards authorities have a suite of standards dealing with electrical equipment that is plugged in or connected to the isolator, such as televisions, cookers, air handling units, hot water generators, etc. Well, at last we get to the what's new part of this presentation, and let's start at the beginning. There are over 700 pages in IS 10101, so this will really only be a snapshot of the key new items. What were known as parts, i.e. parts 1 to 7 in ET 101 2008, are now relabelled as chapters in IS 10101. This has no effect on the technical content, but it brings Ireland into alignment with IEC and Senelec rules. This change will serve to enhance readability of the document into the future. In Chapter 1, the scope, there is no change. The scope of the national rules for electrical installation still refers to the fixed wiring installation right up to the plug or isolator. Don't forget, the remit ends at the plug or isolator. Equipment plugged into or wired into the isolator is dealt with under other standards, but not by the national rules for electrical installation. Definitions are now all contained in Chapter 2. This is a big change because previously the definitions were spread around each chapter. That made it possible to sometimes have different definitions for the same word in different chapters, and you had to search through the book to find any definition you wanted. So this change will make the document easier to read. The definitions list has been expanded and certain definitions have been modified to align with the definitions provided in the International Electrotechnical Vocabulary. A separate standard, IEV 650, is the International Electrotechnical Vocabulary. IS 10101 now relies on the IEV, so the definitions are standardised across Europe. A big new change comes in Chapter 4, Protection for Safety Clause 411.3.4. Residual current devices, RCDs, will now be required to be installed on lighting circuits in domestic premises. There was much discussion about the introduction of this new rule. It will add cost to installations, but in the same manner that the introduction of RCDs added cost in the 2008 rules. RCDs have been found to increase the safety of electrical installations, and the widespread use of RCDs will have the effect of reducing prices of RCDs in the market. Health and safety advisors reported particular safety issues in domestic situations where there was higher incidence of non-registered contractors working on or replacing light fittings. For this reason, RCDs have been introduced on lighting circuits in the domestic market, but may eventually be required also in commercial installations. Okay, now we get to the real game changer. In Chapter 4, Protection for Safety, Clause 421.7 introduces AFDDS, arc fault detection devices. AFDDs monitor the circuit for arc faults caused by breakdown of insulation or failing contacts or even poor terminations. Arc faults are a known cause of fire. For this reason, arc fault detection devices, AFDDs, will now be recommended for circuits installed in locations with particular risk, such as in premises with sleeping accommodation, in locations with risks of fire due to the nature of processed or stored materials, i.e. BE2 locations, e.g. barns, woodworking shops, stores of combustible materials. In locations with combustible construction materials, example wooden buildings. In fire propagating structures, in locations with endangering of irreplaceable goods. Don't forget, the wording is recommended. AFDDs are not yet mandatory. Like all new switchgear, it will take time for the market to get to grips with how AFDDs work. The idea is to monitor the circuit to detect an arc fault before it can cause a fire. The AFDD does this by monitoring the electrical power wave, looking to see the normal sine wave curves. Deviation from the sine wave indicates something is wrong in the circuit. The electronics in the AFDD, like the electronics in an RCD, can determine if the deviation from the sine wave is caused by an arc fault. Then the AFDD disconnects the circuit. So what does an arc fault detection device look like? It's a simple modular switchgear device that is DIN rail mounted in the distribution board. Suppliers are now preparing stocks, data sheets, brochures and demonstration test rigs to inform the market. The important thing right now is to ensure that future designs have both budget and space for AFDDs in the distribution boards. Everyone wants to know about prices and how AFDDs will affect the market. Suppliers respond by saying that market prices are determined by volume of sales, and once Ireland adopts the new AFDD technology, then the price of an AFDD will drop in the same way that RCD prices became normalised. As I said before, this is a big change in Ireland's rules, and industry experts had much debate about the introduction of AFDDs. Some sectors disagreed with the proposed introduction. However, our rules derive from European harmonised documents, and European documents recommend the use of AFDDs. Ireland would need a special exemption to avoid the recommendation of AFDDs. The industry was not keen to seek exemption from recommending a safety device. Ireland is a member of IEC and Senelec, and we can see that the next versions of the rules will make AFDDs mandatory in the future. So the time is right for Ireland to adapt the recommended wording for AFDDs in vulnerable installations and get used to the technology. Moving on to Chapter 5, Selection and Erection of Equipment Clause 512.1.5, we see that this clause will require sign-off by the appropriate person that the installation complies with the Electromagnetic Compatibility Directive, the EMC 2014/30/EU. The EMC directive has applied for many years to equipment plugged in or connected beyond the isolator, so this clause will apply now to the fixed wiring installation. The responsible person may be the designer or in some cases the electrical contractor, where he is responsible for both the design and installation of the wiring. Moving on to the next slide, we find another big change and one for the better. Chapter 5, Selection and Erection of Equipment, Clause 527, now requires all cables in buildings to be rated Class DCA, S2, D2, A2, in accordance with EN 50575. Lots of letters and symbols, but what does it all mean? Well, the core of the rule is to define and improve the classification of cables with regard to their response to fire. Experience has shown that cables in the fixed wiring installation present a risk when a building is on fire. Cables are often installed above the escape route. Depending on the duration or intensity of the fire, cables can obstruct the escape route with smoke or poisonous fumes. We are familiar with low smoke or zero halogen cables, but how low is the smoke and how close to zero is the halogen risk? European standard EN 50575 now defines the fire rating of cables based on several characteristics. The first digits, DCA, refer to the flame propagation and heat emission test of a cable. This is standard stuff we've seen over the years for cable ratings. How long will a cable withstand a fire and of what intensity? The second digits S2 refer to the rate of emission of smoke and transmittance of a cable. This defines the amount of smoke the cable will emit and how obscuring the smoke will be. The third digits D2 refer to the cable tendency to emit burning droplets or particles. This relates to the habit of older PVC cables to release burning droplets of plastic onto the fireman working below. And the final digits of the classification are A2, referring to the acidity and corrosiveness of emitted gas. This relates to the habit of older PVC cables to emit hydrochloric acid when they've been on fire for some time. Not very helpful to the fireman making his way along the corridor below where the cable has been installed. This improvement in cable standards has been a long time coming. Electrical cables form a large risk in high-rise and densely populated buildings, which are increasingly a feature of Ireland's architecture. There is a movement to protect escape routes in all types of buildings, from offices to hotels and apartments. Impetus has come from fire officers and regulators, and cable industry specialists worked with NSAI to develop the new standard. The UK Grenfell disaster pushed this item to the top of the agenda. We needed an increased fire standard for all cables. Ireland has now in fact adopted a mid-range standard, as EN 50575 has cable ratings from ACA to FCA. Ireland will look for class DCA as the new minimum standard for all buildings. The new mandatory cable standard does not prevent specifying a higher class, say class CCA, for particular installations, but the minimum mandatory for all buildings shall be class DCA. The industry debated long about the cost effect of this new cable standard. However, it is expected that once all new electrical installations are calling for this new increased standard cable, then volume manufacture and sales will lead to reduction in costs for these cables in the long term. This next rule, you'll be pleased to hear, a new rule that never actually happened. There was a proposal to introduce a new rule that domestic distribution boards should be non-flammable. This is because the domestic distribution board is a particular risk, residing as it does at the main entrance and therefore escape from the home. Review of the existing rule, however, showed that boards are already required to comply to European standard EN 61439, which is a suite of rules that ensure that boards are non-combustible. EN 61439 requires boards to be type tested so that the components and the connections and the enclosure are all not just resistant to fire. There's no point in having a board resistant fire while all the rest of the building's on fire, but also that the board and its components do not actually cause the fire in the first place. And what is non-combustible anyway? Does that mean inflammable at 70 degrees Celsius or at 800 degrees Celsius or at maybe at 90 degrees Celsius for 3 hours? There was really no point in trying to establish a new standard here. The tests already within standard EN 61439 are extensive, and therefore the rule in Ireland remains as previously shown in ET 101. Under clause 530.6, distribution boards, switchgear assemblies, 530.6.1, general distribution boards, switchgear assemblies shall comply with IS EN 614391. That's your local household distribution board or consumer unit. It must be a type tested assembly complying E1 61439, and this gives the best level of protection. Moving on to RCDs, which were once seen as the new technology. In the beginning, residual current devices, RCDs, or earth leakage circuit breakers, ELCBs, as were used then, were a great unknown in the electrical industry. We didn't know how to wire them and they had a tendency to trip. But eventually we learned that they were of course tripping on small earth leakage fault currents that previously went undetected. Now residual current devices are trusted safety devices, saving many lives. By the way, remember that notice that was on your distribution board? Test your RCD. Yes, don't forget to test your RCD. RCDs have a tendency to stick and may not operate correctly in a fault current unless they've been tested regularly. After this presentation, go straight home and test the RCD in your home. Meanwhile, RCD technology has advanced greatly and the electronic sensors are now better tuned to detect earth faults. The problem is that new electronics sometimes impose harmonic waveforms onto the power grid, which can trick or blind the older types of RCDs. New types of RCDs are now on the market, and the older AC type is no longer permitted for new installations. Look at the graphical representation here, and you can see the types of waveform that various RCD types respond to. Clause 531.3.3 states that residual current devices, RCDs, type AC, are not recommended in new installations, but the new clause stops short of asking for the old type AC to be removed from all existing installations. Now, this is a worry because we know that the old AC type can sometimes be blinded and not operate on earth fault. Replacing all existing RCDs throughout the country would be a huge task though, and at the moment the new regulation only advises against the use of AC type in new installations. It is a good idea though to replace any old AC type RCDs if you are rewiring an installation. Another huge advance in RCD technology is that some manufacturers can now incorporate both RCD and also arc fault detection AFDD technology in the same device. Manufacturers and suppliers are responding to the new possibilities that electronics brings to provide devices that improve the safety of the electrical installation. Look out for suppliers' presentations and demonstrations, many of which are on the web. Surge protection is dealt with in clause 534, which is a complete new section. It provides details on selection of surge protection devices, SPDs, including wiring diagrams, especially where lightning protection will be installed in a building. Surge protection was previously considered for protecting against lightning surges. Ireland is not very prone to lightning strikes, so we have not usually paid much attention to surge protection. But there are instances of over voltages on the power network which can affect delicate electronic equipment. That's your flat screen television, your computer, your Wi-Fi unit. There is now so much electronic equipment connected in all buildings that surge protection is well recommended for every electrical installation. Clause 534 has wiring diagrams to cover nearly every installation, so it's worth a look as there is good guidance there. Chapter 6, Inspection and Testing, has undergone a big change. Inspection and testing has been completely revised to align with the CENELEC standard. Model certificates have now been removed entirely from the national rules for electrical installations, and there are several reasons for this. The regulator CRU now oversees the inspection and verification process, and inspection and testing certificates are now issued by the Inspectorate Safe Electric and not by the standards authority NSAI. This is slightly different from the format NSAI use in emergency lighting standard IS 3217, for example, or the fire alarm standard IS 3218. Emergency lighting and fire alarm certificates are incorporated into the back of those standards. But the Electricity Regulation Act 1999 has defined clear roles of responsibility, and Safe Electric controlled the design and issue of the electrical inspection and testing certificates. The format of the certificates may change over time also, and this would mean that any sample or model certificates included in the standard IS 10101 might quickly become outdated. Therefore, model certificates are no longer included in the standard. The Inspectorate Safe Electric has also been exploring the idea of moving certification to an online format. This is another reason to exclude model certificates from the national rules for electrical installations. Moving to the back of the book, Chapter 7 deals with what are termed special locations. Special locations have always existed in ET 101, but there are a few changes here. Ireland's rules have been updated to align with the relevant CENELEC HD 60364 series of harmonised documents. Part 7 includes special locations like 703, rooms and cabins containing sauna heaters, 708, caravan and camping parks, and 710, installations in medical locations. Part 7 delves into great detail for those special locations and will interest specialist contractors. A new section introduced is Part 730, onshore units of electrical connections for inland navigation vessels. This is probably not something you'll deal with every day. Of note here, though, is Part 722, charging for electric vehicles, which is new to Europe and was issued as an amendment to ET 101. The electric vehicle market is set for big growth in Ireland, and the wiring rules for electric vehicles in IS 10101 now follow European guidance. Energy efficiency has been relegated to Annex 8 at the back of IS 10101. This is a new departure for IEC and Senelec. Energy efficiency and carbon footprint is a hot topic across the globe. Electrical installations are in focus as the distributors of energy, and hence they have an effect on carbon footprint. There is some debate as to whether energy efficiency should be included at all in the wiring rules, as the scope of the rules is, you will recall, the safety of electrical installations. So the energy efficiency section, as proposed as a part, but is now only an annex, and comes with the advisory note that it introduces recommendations for the design of an electrical installation. Note that recommendations, not rules. So Annex 8 content is not mandatory. In fact, the Annex 8 text goes on to advise that the requirements and recommendations of this part shall not impair the requirements included in other parts of IS 10101. So there is nothing in Annex 8 that is mandatory, and nothing in Annex 8 can overrule any other rule. For designers, though, Annex 8 is all good stuff, and it asks you to do all those things you were actually supposed to be doing anyway. Reducing copper losses by cable sizing correctly, centralising the mains power supply on the key electrical loads, designing in electrical monitoring and metering. A notable consideration is to consider the need for load shedding or control where alternative energy may be introduced in the installation later. CHP, PV or wind energy may be connected later, for example. Larger electrical loads, EV charging, water heating, etc. may need to be disconnected when alternative energy is not available. Facilities for all this would be difficult to retrofit later, so that any new electrical installation designs should consider these issues now. This will make energy control and monitoring easier in the future, which is something we should all aspire to. Now we move on to the good stuff. When will all this happen? Control of the implementation date and method is by the regulator CRU. Remember, one of CRU's tasks is to have a set of rules, so the transition from ET 101 to IS 10101 is determined by CRU. Making such a big transition, which affects everyone in the electrical industry, is not easy. Electrical contractors, trainers, designers, suppliers, manufacturers, inspectors. This change involves many people. Everyone needs time to train up, stock up, and become aware of how and where the new rules will affect them. As part of the process, CRU received input from many sources and has considered all aspects. The implementation plan for IS 10101 is as follows. The transition period will begin from the 1st of April 2020. Electrical installations may be designed to the new standard from this date. After 10 months, from the 1st of February 2021, all new electrical installations must be designed and certified to the new standard. After 28 months, from the 1st of August 2022, all electrical installations must be certified to the new standard. Installations may be designed to the old standard until the 31st of January 2021, provided they are certified to at least a pre-connection stage by the 31st of July 2022. So we have already kicked off. The game is on. It's time to get a copy of the new rules, IS 10101, and become familiar with it. There will be presentations online, and there's a plan for roadshows across the country later on this year. Your registered electrical contractor will have updates from Safe Electric. There will be lots of questions, and probably the first question will be, what happens to existing installations? The regulator has already thought of this one and has made a decision. Existing installations may not comply with IS 10101. This does not necessarily mean that they are unsafe for continued use or require upgrading. However, it is recommended that all reasonably practicable steps should be taken to bring such existing installations into conformity with IS 10101. So there's no need to panic. Your existing installation is not about to be disconnected from the power grid, but you have seen that there are many new safety advances in the new rules, IS 10101, and everyone must move towards compliance to improve electrical safety. To finish off this presentation, here is a quick summary of what's new in IS 10101. Residual current devices, RCDs, on lighting circuits in domestic premises. Arc fault detection devices, AFDDS, will now be recommended. Electromagnetic compatibility, EMC directive. Cables to be rated class DCA, S2, D2, A2 in accordance with EN 50575. Distribution boards in domestic installations to be non-combustible. Residual current devices, RCDs, type AC, are not recommended. Model certificates have now been removed. Energy efficiency. What happens next? Well, the Irish Standard IS 101 is now available in hard copy book for purchase like any other standard through NSAI. Go to standards.ie or nsai.ie. And with each book, you will also get an online version. An online app may be developed in the future, but the route now is by buying the book. Look out for more presentations online and for roadshows when they take off later in the year. Further information can be got online from the regulator CRU on cru.ie and also from the inspectorate safeelectric.ie. And of course, NSAI has a lot on their website, including a list of replies to frequently asked questions. Don't forget, the first place to ask an electrical question is always to your RECCE registered electrical contractor. Be safe, always use a registered electrical contractor. Update message from the regulator from the 25th of March 2020. The transition period will begin from the 1st of April 2020. Electrical installations may be designed to the new standard from this date. After 10 months from the 1st of February 2021, all new electrical installations must be designed and certified to the new standard. After 28 months from the 1st of August 2022, all electrical installations must be certified to the new standard. Installations may be designed to the old standard until the 31st of January 2021, provided they are certified to at least a pre-connection stage by the 31st of July 2022.